All right, this is Unit 6, Day 5, Part 2. All right, so we're on Part D here. So from here on out, I'm not going to do the horizontal rewrite. I'm going to do the LCD method. So now this you just have you have 5 denominators. So you're going to pick your LCD. So in this case, my LCD, think of the numbers. I have 12, 6, 12, and 3. They can all go into 12. 3 can go into 12, 6 can go into 12, and 12 can go into 12. And now, because each of those have an x, 12x is my LCD. So I'm going to rewrite the original problem. So I have x over 12. Sorry, that's an ugly x. Right there. So I have x over 12 plus, I'm going to leave a little space, and I have 1/6, because don't forget I have to multiply it by the LCD. Don't forget, guys, subtraction, that's going to be a plus -2. Down on the bottom, that's going to be a plus -4. So you might want to change those signs. Okay, so I'm going to get plus, and I'm just going to sneak all of them in, being multiplied by a 12x over 1. That's the LCD. So 12x over 1, it doesn't matter if you do it on the left side or the right side. And then my last part of that numerator there was a -2 over x. So there's my numerator. So I have 3 separate blue boxes up in my numerator, each minor fraction being multiplied by the 12x over 1. Okay, my denominator, I have x over 12, originally given, and then I have a plus, I'm going to leave a little space there, then I have a -4 over 3x, which was originally given. Don't forget you to change that sign. So each of these are going to be multiplied by a 12x over 1, and then I did a 12x over 1. Let's box them in. So now we have 5 little fractions that we have to reduce to. So here, the 12s are reduced, and be careful. I have 1 times this x, don't forget about this guy, times an x. So x times an x, I'm left with an x squared. Okay? Middle box, I can reduce the 6 and the 12, leaving behind a 1 and a 2. But again, don't forget, I have 2 times an x times a 1. That's a big 2x right there in the center box. And then last, I can cancel the x's, but I have a 12 times a 1 times a -2. So really, it's just 12 times -2 is -24. Okay, so it looks like I have a trinomial up there. All right, same thing in the bottom boxes. 12s are gone, leave behind 1s. I have an x times an x, which is an x squared. And then the last box here, I have a x and an x cancel. They both leave behind 1s. And then 12 and 3 leave behind a 1 and a 4. So now I have 4 times 1 times a -4, which is a -16. So now I have a trinomial over a DPS. Okay, so I do have to factor those. So the top trinomial, you're saying what multiplies to a -24 but adds to a +2. It's going to be x plus 6 times x minus 4. Okay, the bottom is the difference of a perfect square, so I'm going to get x plus 4 times x minus 4. So my matching marriages are the x minus 4s leaving behind 1. So my answer is going to be an x plus 6 all over an x plus 4. Remember, guys, the x's cannot cancel, and the 6 and the 4s can't reduce because x is married. That's a marriage to 6, and x and 4 are married. So that's a final there as well. Okay? Last one here. E and F look a little crazy. Okay? The denominators are no longer monomials. Okay? So what you're going to want to do is you're going to want to factor anything that's not factored. So you're looking for GCFs, DPSs, and trinomials. So I know part E that this is a trinomial. So I'm going to say what multiplies to a -8 but adds to a -2. It's going to be x minus 4 and x minus 2. I'm sorry, x plus 2. Because -4 times +2, and you know the whole game. So the LCD, you want one of everything. Okay, you want one of everything, kind of like adding the other day. So you have an x plus 2 and x minus 4, and the bottom has one of each. So that means my LCD is going to be x plus 2 times the x minus 4. You want one of everything. Put that whole bad boy over 1. Okay? So now what I'm going to do, and it's going to take time just to write this out, I'm going to multiply each original minor fraction, okay, use the factor form there, by this LCD. So watch what I have. So I'm going to take the LCD, which is x plus 2 times x minus 4 all over 1, and I multiply it by this first minor fraction, which is going to be 4 over x plus 2. Okay? There's a plus sign in the middle, and this would be your first blue box. Okay, the next one, I have, again, the LCD, x plus 2 times x minus 4 all over 1 times the original minor fraction, which is 2 all over x minus 4. Here's my second blue box. You really have to make sure, guys, you're taking the time to write things neatly, box things in. It keeps it a little bit more clear. Okay, and then that's all over the LCD, x plus 2 times x minus 4 all over 1 times the original. Now, the original, guys, is this minor fraction here. So it's over 12x minus 24. But don't write the trinomial. Write the factor form. It's over x minus 4 times x plus 2. Now, you know multiplication is commutative, so you could have that flipped. And that's my last blue box. Okay? Alright, don't get freaked out here. So up here in my first blue box, the x plus 2's are matching, so they're gone. And you really only have this x minus 4 times a 4. So how do you multiply x minus 4 times 4? You distribute. Okay, you got to distribute that 4 to both of those. And I'm going to have to write a little bit smaller here. I'll write over here. I'm going to be left with 4x minus 16. Again, 4 times x, 4 times negative 4. Alright, that's my first blue box. Put a plus in the middle. My second blue box, x minus 4's are gone, leaving behind 1's. So I really have the 2 being distributed to the x plus 2. And I'm going to get 2x plus 4. There's my numerator. If you wanted to clean that up and combine like terms, a 4x plus a 2x is a 6x. Negative 16 plus 4 will be negative 12. Okay, so look at how nice that nice new numerator is. Alright, last thing here for the denominator. It looks crazy, but watch how easy this is. Matching x minus 4's, matching x plus 2's. So what am I really left with? I'm left with 1 times 1 times 12x minus 24, all over 1 times 1 times 1. So the only thing I'm left with is that 12x minus 24. So now the only thing I have to do is factor. I have a GCF over a GCF. So if I divide out a 6, I'm left with x minus 2. If I divide out a 12, I'm left with x minus 2. You do have matching marriages, leaving behind 1's. Please do not leave me 6 out of 12. Okay? You don't have 6 out of 12, you have a half. So that crazy complex fraction reduces to a half. Okay, that's LCD method. Alright, one more here and we're done. So, guess what, guys? Wild guess. X plus 6, x plus 2 are already there. Guess what that factors to? That factors to x plus 6 and x plus 2. 90% of the time, that's going to happen. Okay, we don't kill you with things that are totally different. The only thing I want to pay attention to, look, there's a minus there. So that's plus negative 1. Don't forget that. You got to hand out that minus sign. Okay? So 6 times 2 is 12, but 6 plus 2 is 8. So that one factors. So ready? My LCD. You want one of everything. Is x plus 6 times x plus 2 all over 1. So now I'm going to multiply each fraction, each minor given fraction, by that LCD. Some of you are going to be quick enough to realize you might not want to write this out every time. This one already has the x plus 6, so what are you really handing out? The x plus 2 to the numerator. Okay? This one has the x plus 2, so what are you really handing out to that numerator? The x plus 6. Okay? But if that confuses you, what I just said, rewrite everything out and multiply each given fraction by that LCD. So there's my first box. Okay, now I'm going to write the LCD again. So x plus 6 times x plus 2 all over 1 times the original fraction given. Now the original fraction, don't forget, it's negative 1 because you had to hand out that subtraction sign there. All over x plus 2. There's my second blue box. All over the denominator, I need the LCD again, x plus 6, x plus 2, all over 1, times the original. And again, guys, you want the factor denominator. So it's x squared minus 4. That's right here. And don't give me this trinomial, give me the factored. So it's over x plus 6 times x plus 2. That's my last blue box. Alright, now you're going to reduce any top with any bottom. So look, gone, leave behind 1. So I mentioned you're going to distribute this now. So you got to hand out those x's. Okay, x times x, I'm going to be left with x squared plus 2x. That's my first blue box. Okay, my second blue box, x plus 2's are gone. So you're really just handing out the negative 1 to both of those. So it ends up being a negative x minus 6. So when you combine like terms, nothing pairs with the x squared. I have 2 take away x would be a positive x. So it's like 2 minus 1 is 1. And then carry the negative 6 for the road. Okay, we'll factor that in a minute. The denominator, look how nice this is. X plus 6 is gone, leave behind 1s. X plus 2 is gone, leave behind 1s. What am I left with? I'm left with just this x squared minus 4. So I bring that over. So now I have a trinomial that I have to factor over a DPS. So the trinomial, what two things multiply to give you negative 6 and add to a positive 1? It's going to be x plus 3 and x minus 2. Bottom DPS, x plus 2 and x minus 2. You do have a set of matching marriages. They leave behind 1s. And what am I left with? I'm left with an x plus 3 all over an x plus 2. You're done. That's your answer. Don't forget you can't touch those. Those are marriages.